Hello there. Welcome to your Chapter 3, Lesson 8, Notes on unions, not onions, on unions and intersections of sets. By the end of the day, you'll be able to find unions and intersections of sets. So here we go. Let's make some unions and intersections. In fact, let's talk about cats and dogs. Well, let's talk about dogs first. What do dogs have? How would you describe a dog? When I think of a dog, I think of an animal that wags its tail and is happy all the time and generally fun to be around. Some dogs can bark and they play fetch. Other things that dogs do is they have eyes, like I think of their puppy eyes. They have, most of them have 4 legs. And what about cats? Well, when I think of cats, I think of relatively mean animals, and they have these cool, like, cat eye things. They make this meow sound, which is fun. They have 9 lives, which is super great. What else do I know about cats? Oh, they sleep a lot. They invented the cat nap. But you'll notice that cats and dogs, they are both animals. So we can put this idea of this animal description, that can go in here because it fits for both of them. And cats and dogs also both have 4 legs and they have eyes as well. So that goes with both of them. Is that it? I think we could find other similarities. They both breathe. That's kind of a function of being an animal. They're both common pets, right? Okay. So here, this is what's called a Venn diagram. A Venn diagram is used to show the similarities and differences between 2 concepts or between 2 sets. So that's a Venn diagram. You can see that this center part is their overlap. So this is what we would call their intersection. It's where they intersect. Yeah, cool. Excuse me. All right. So on the what is this? Left. On the left side, we have this whole circle right here, and this whole circle represents things that describe dogs. So there are a whole bunch of concepts in here that are all about dogs. So this one is like the dog side. Okay, and that's fun and very cute. But then this circle is all about cats. So that circle was much worse. Not that like cats are worse than dogs, but you know what I mean. But this is like the cat side of the equation. So you've got the whiskery animal over here, like that guy. Is that fun? What a cute visual that is. So today when we talk about the union of 2 or more sets is everything between all of them always. So the union contains all the elements of both of the sets. We write this using the cup symbol. This guy is called the cup because it looks like a cup. And so we would say A union B. And what that looks like is you have some set A, some set B over here, right? A union B is taking everything in A and everything in B, including their overlap, and that's what their union is. Okay? So if I have a list of friends that I have, and cup, think like a cup holds everything. So you could take this whole diagram and it would like fill the cup and stuff. Okay, so it all goes in the cup, right? So that's what the cup is for. The union holds the whole thing. You've got this cup holding the whole union together. Also, it looks like a U. Okay. So you have my friends Allie, Amy, Haley, Renee, and Ryan. And Caleb's friends are Cam, Haley, Madeline, and Ryan. That popular guy, that Ryan. Okay. So what is the union of my friends and Caleb's friends? Well, if I did, like these are my guys over here, and these are, not Rye guys, these are Caleb's guys over here. You'll notice there is some overlap. Who appears twice in our list? Well, that would be Ryan and Haley. Ryan and Haley are in both sets. They show up twice. That's hard to see. So Haley's my friend and she's Caleb's friend. Ryan is my friend and he's Caleb's friend too. So we don't want to count them twice, but we would just say the union of our friends is Allie, Amy. I'm going to go alphabetically. So we have Allie, Amy, Cam, Haley, Madeline, Renee, and Ryan. Do we have 9, 8, 7? We have 7 people. Do we have 7 unique people? 1, 2, 3, 4, 5, 6, 7. Yes, we do. That's it. That's all of them together. So technically, if we wanted to do this right, we would have to like squeeze Ryan and Haley into this little center part because they belong to both of these guys. So they go in there. And it's very important that you're listing each of these elements only once. They only appear one time. Cool. So an intersection. An intersection is like what you think of when you have, you know, the road going. If you have one street coming this way, and then you have another street coming this way. Yeah. This intersection right here with like the stoplight and stuff, that's where they both occur. It's where they intersect. The same kind of idea is true in math. The intersection. The intersection of two or more sets is the set of elements that are common to all of those sets that they share. Okay, it's where they run into each other. Just like the intersection up here is this part right there. So if we were to take our friends and move it down here, the intersection of my friends and Caleb's friends is just Ryan and Haley. That's it. That's the intersection. That means we have 2 friends in common. Haley and Ryan. Done. Actually, we would write our answer like this or put like our final answer in a box. Right? So intersection, instead of being a cup like a union, is this symbol. We call this guy not a cup, but a cap, because it looks like a little cap that you put on a person, right? So like that a person would wear. You have this little cap that they put on their head. Yay! Okay, now that just looks like hair, but I think you get the idea. Okay, so the cap symbol, we would say A, you intersect B, or A cap B if you wanted to. So in our diagram, the intersection is just this middle part right here. So if you have A and you have B, then this area is A intersect B, or A cap B. Fun fact, right? So good. Now sometimes you will have what are called disjoint sets. I don't know if you've ever had like a disjointed anything. Like I disjointed my elbow. Ugh, gross. They have no elements in common. They're completely separate. It's kind of the same thing as mutually exclusive events. There's no intersection there. They're done. That's it. The intersection of the disjoint sets is the empty set. Okay, that's it. Done. So you would say that A intersect B is the empty set. Or you could say A intersect B is the empty set. Ta-da! So let's deal with another set. Don't need to get upset. Okay, so you have set X is any even number, these guys. That's a lot. I can't write all of them in here because it's literally going to take infinity. So instead what I'm going to do is I'm going to just be like negative 6, negative 4, negative 2, 0, new line, 2, 4, 6, etc. Okay? And then in set Y, we have 1, 2, 3, 4, 5, 6. So I can do that. 1, 2, 3, 4, 5, 6. Oh, but there's some overlap. Look, they both have 6, they both have 2, and they both have 4. So these need to go in here. Those are some intersections because they occur in both the pink and in the blue. And then set Z is negative 1, 0, and 1. Oh, but check it out. 1 occurs in Z and in Y. So we're going to put 1 in their intersection. And 0 occurs in Z and in X. So we're going to put 0 in their overlap area instead. Is that it? Did I cover everything? I'm going to turn these guys right side up. Or maybe I'm not. I guess I will. Haha, that's a 5. Ta-da! There you have it. So negative 2, so negative 2, 0, 2, 4, 6, also 8, also 10, also 12, and getting bigger. There we go. Okay, so now it asks, what is Z union Y? What is Z cup Y? So that's going to be all of Z and all of Y all together. So I guess I should write it like this. It's all of Z and all of Y, which from smallest to biggest gives us negative 1, 0, 1, 2, 3, 4, 5, and 6. Thank you. And then it asks, okay, now what is Z cap Y? What is the intersection of Z and Y? Well, the only thing that they have in common is 1. So that's literally just the number 1. Yay! Okay, well then, what is X cap Y? What's the intersection of X and Y? Well, that's 2, 4, and 6. And then finally, what is X cap Z? What do X and Z have in common? The number 0. Notice that this is not the empty set. This is the set containing 0. So there's one thing in this set. Think of a set like a basket, right? In my basket is the number 0. Ta-da! Not that there's nothing in here, but it's the number 0 is in there. Whew, whew, got it? Okay, so far we've talked about the union, which is everything together. We've got intersection, which is only where they overlap. And then we've got disjoint sets that don't overlap. Sad day. Okay, cool. So when are we going to use this? Well, I have 2 examples for you. Oh, and by the way, you guys, this question, great quiz question. Hint, hint. Okay, so out of 500 total commuters polled, some drive to work. Some drive to work, some take public transportation, and some do both. 200 commuters report that they drive to work, and 125 use both types of transportation. So how many commuters take public transportation? Okay, well, let's draw it out. Let's visualize it. So let's let this one, oh, watch this cool trick. I'll try spinning. That's a good trick. Just kidding. Haha, oh. So what we're going to do here is not move this. Let's go. Okay. The drivers. How many drivers do we have? 200 people drive to work. So this whole circle is 200 people. But don't write it like that. That's going to get real messy. So instead we're going to say this whole circle represents 200 people. 125 use both types of transportation. How many commuters take public transportation? Well, there's one other key piece of information we haven't used yet. There are 500 commuters total, which means in our universe, if we were to put a number here plus this number plus this number, they would all add up to 500. So we know that we have 200 total, and we know that 125 of them are both. But guess what, guys? It doesn't really matter. Because 200 commuters drive to work, and we want to know how many take public transportation. Oh, you know what? It does matter. I'm just kidding. Okay. So of all the drivers, of the 200, 125 also take public transportation, which leaves 75 people that only drive. Using this same logic, we can figure out how many people take public transportation only. Right? We know that they all add up to 500, so that there's going to be 300 people in here, because if we were to take away all the drivers, that's all of the, all 200 of them, there would only be 300, so that includes this guy. But I can't get this guy without also taking that. Well, there you go, this 500 to help you visualize. Okay. I don't really know how to better explain it. If you take away all of these drivers, which is worth 200, then there's going to be 300 left out of our 500 total. I hope that helps. Okay, so now that we know how many people only take, I assumed bus was public transportation. So now that we know how many people only take public transportation, now we can see how many take public transportation total. So we'll add up the only public with the drivers in public, which gives us 425. So how many commuters use public transportation? 425 commuters. Ta-da! Okay. What are the solutions? Write them as the union or the intersection of two sets. Why did I put two number lines on here? We only need one. Sorry. Okay, well, let's solve our absolute value. We've got this absolute value isolated already, so let's split him into a negative and to a positive solution. Oh, but guess what? It's an absolute value that is already negative, so we know it's going to be an and. So we have negative 3 is less than 2x minus 1 is less than 3. Now let's solve this awesome guy by adding 1 to all sides. So we have negative 2 is less than 2x is less than 4. And then we divide by 2 on both sides. By both, I mean all three sides. Giving us negative 1 is less than x is less than 2. So x is between negative 1 and 2, non-inclusive. So if we were to put this on a number line, for example, we would have a open circle at negative 1 and open circle at 2. That's 2. That's 2. And then shade between them. Now, how can we write them as sets? Well, let's split this guy up into two inequalities again. Here, this is basically saying negative 1 is less than x and x is less than 2. Now when you have and, we're looking for the intersection of these two inequalities. We have -1 is less than x, which is going that way, and x is less than 2, which is going this way. And this guy is the intersection of them. So we're going to intersect. Cool? Cool. Because we're looking for what makes both of them true. So just there, overlap. Okay, so let's rewrite this as a set. This is all x's where x is greater than -1. I pulled a sneaky on you. I switched them around because I like to put x first. And this is, oh dearest, the wrong tool that I'm using. X, all numbers x where x is less than 2. Hey look, there you have it. There's our sets. Ta-da! I'm gonna move them over here though, so it looks nice. And that's it. We have the intersection of these two sets. So remember, intersect is where they overlap. Union is all of them together. So the union of all the drivers and public transportation takers, commuters, 500 total. And yes, oh, disjoint sets have nothing in common. Shame. Hope you have a wonderful time on your homework. Oh no!